Let's go ahead and start with section 9.4 on nonlinear systems of equations. So nonlinear means now our equations could be curvy, right? We could have circles, parabolas, all kinds of things. In systems of equations, we're trying to find out where are the points they have in common, or where do these graphs intersect? So for instance, this system of a line and a circle has how many solutions? So I graphed this line here and the circle here, and how many points do they have in common? 2 points right here and here, right? In fact, can you name them? Yeah, so what are they? 6, -8, and -8, -6. And how can you check that? Maybe the dot is actually a decimal, not a whole number. Plug it in, make sure it's true in both equations. What if I didn't give you the graph? How can we solve? If I just gave you these equations, we can use the two methods we learned before, substitution or elimination. Okay, if I have, you guys know the plural word for ellipse? Is it ellipses? 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 Okay, so how many solutions do these two ellipses have? A system of equations. Yeah, 4 points in common. Okay, and lastly, here we have a parabola and a circle. How many solutions does this system have? 0, there are no points in common. They do not intersect at all. Sorry, there's this one also. How many solutions does this have? Maybe a sine curve and a line. One has infinitely many, yeah. Okay, let's solve this first one. Would you like to solve by substitution or elimination? Substitution. You'd want to plug which equation into which? Plug, yeah, either into, so I'm going to plug R2 into R1. Maybe I'll write these R1, R2, or 1, 2. So the reason for that is because y has already been isolated, so we can plug it into that top equation. 5x plus y is equal to 3, but we'll plug in x squared minus 3x minus 5 for y. If you solve for one variable, you can plug it into the other equation. And what that does for us is we have an equation of x is only, presumably we could solve it. X squared plus 2x minus 5 is equal to 3. How do we solve this type of equation? Yeah, subtract 3. X squared plus 2x minus 8 is equal to 0. It's quadratic, so hopefully it's factorable. If it's not, use the quadratic formula. Factors of -8, they add to make 2. Positive 4, -2. X equals -4 or x equals 2. So what does this mean and what am I looking for? One or both are the correct x. Which one is it? Okay, so basically we have a line, a straight line, and what's this graph look like? A parabola. They can intersect no times, one time, or twice. So we need to plug back in to find where they intersect. What's the y value? So in green, we'll start off, what if x is -4? Which equation would you like to plug into? Yeah, the first one is a lot easier to plug into, right? So let's plug in a -4 here. -20 plus y is equal to 3, or y is equal to 23. So we have a corresponding order pair here. -4, 23. Wait a second. Is that a solution to the system? We don't know. Okay, so how would we check?
Oh, okay.
Okay, to check, you plug in x equals -4 and y equals 23 into both equations, because that's what it means to be a solution in a system. It must be true for both. Okay, so let's talk about what we did here. I don't have my pointer. We plugged one equation to the other, so we combine them. When you combine the equations and you find an x value, means these are exact x values where they intersect. So these are for sure correct solutions, assuming I didn't make a mistake. So I need to find the corresponding y value. We found the first one. When x is -4, found y is 23. So this is for sure a solution, assuming I didn't make a mistake. You can plug it in. So we know that x equals 2 is another point where they intersect for sure. So we combine the equations. We plug in here and we'll say 5x plus y is equal to 3. And we'll plug in 2. 10 plus y is equal to 3, or y is equal to -7. So we have 2 points of intersection, 2 order pairs that make both equations true. Any questions about this? So we'll apply substitution when it's easy to solve for one variable. There's many ways to solve these. In fact, there's many infinite ways to solve these. Let's practice an elimination method. So if we want to do elimination, you can do R1 plus -R2. So R1 is 5x plus y is equal to 3. Here we could do -y, -x squared, +3x, +5, and add the sides together. And it's elimination method because this is how we systematically eliminate the y variable. 5x is equal to -x squared plus 3x plus 8. And we have the same quadratic. X squared plus 2x plus 8 is equal to 0. So we'll get the same solutions. It's all the same way from here. All right, any questions about this? One thing people like to do is solve both equations for y. So R1, if you solve for y, you could write it as y is equal to -5x plus 3. R2 is already solved for y. Y is equal to x squared minus 3x minus 5. And since they're both the same, you can set both these sides equal to each other. And that's really just doing the substitution method. It feels a little bit different, but it's not. So this is substitution. Any questions about this?
Which one you got in the division you had was -8, but then through the elimination you had +2.
Oh yeah, it should be -8, right? Subtract 8 from both sides. Thank you. Any other questions? It's been a long week. Does anyone know what this equation looks like? Circle? What does this equation look like? Yeah, it's a circle, but we have when you multiply by number in front of x squared, it's going to stretch it or shrink it. Yeah, so this is an ellipse. And the y, same thing. So one's a circle, one's an ellipse. How many solutions can we have? 4? Sure. What about, could we have 3? Yeah, if it just touches right there. Could we have 2? We have 1? 0? Okay, so we don't know. Let's try and figure this out. Do you think substitution or elimination would be easier? Elimination? They're about equally as easy. Let's do elimination because you said so. Do you want to eliminate x or y? Probably y because we can use smaller numbers. So if this is R1 and this is R2, we want to eliminate y. We'd like to make this a -4. So let's multiply R2 by -4. R1 plus -4 R2. R1 is 9x squared plus 4y squared. It's equal to 144. And -4 times R2, -4x squared, -4y squared, is equal to, thank you. And so if we add the sides together, by design, the y's will cancel or eliminate. And we get 5x squared is equal to 108. Oh man, sorry. Let's divide by 5. I realized in my notes I eliminated x first. It turns out that's way nicer. and I'll point out why in a second. If we divide by 5, what's the next step? Square root. And we get x is equal to, good, plus or minus square root of 108 over 5. This is awful, right? So we have two x values where it intersects. X is equal to positive square root of 108 over 5, and x is equal to negative square root of 108 over 5. So we need to find the corresponding y value for each of these. Which equation looks easier to plug into? Okay, so I'm going to write plug into either equation. Is it either or either? English is hard. Yeah, x squared plus y squared is equal to 9 is definitely the easier one. And since it's squared, it doesn't matter which one I plug in for x, I'm going to get the same answer. Square root of 108 over 5. If I square that, what do I get? 108 over 5. Let's subtract that from both sides. So I'm going to write this as 45 over 5. 9 is the same as 45 over 5, minus 108 over 5. Y squared is equal to negative what? Was it 63 over 5? And we square root both sides to get y is equal to plus or minus I root 63 over 5. So I have 4 solutions. This is corresponding to 2 of them, right? If x is root 108 over 5, y can either be positive I root 63 over 5 or negative I root 63 over 5. Does anyone see the problem here? What's that? We do. We just write it next to the same x value. Let's say I graphed it. Where do I put this order pair? This is the problem here. It doesn't exist because this is a real axis, real number, and this is a real number. Okay, so this is the case when the two do not intersect at all. We would say there is no real solution. There are imaginary solutions, but we're trying to find the real ones where they intersect. For the nonlinear ones, we're going to throw out imaginary solutions. So on your homework, I believe it says the solution set is this, meaning empty set. We're going to say no solution here. And just confirm, if I plug in the negative, plus or minus, either way, when I square it, I get the positive 108. Let me just write this out. There's 4 solutions technically. Negative root 108 over 5, I root 63 over 5, negative root 108 over 5, negative I root 63 over 5. So there's 4 answers if we allow complex. But we're just looking for where they intersect. So we'll write no real solutions. Any questions about this? I'll want answers as it's in the homework in the book. If you put all 4 of these, I'd give you full credit though. I just wrote all 4 because that is a test question where I've given where you have actually 4 real solutions. So I just want to go through how you find them. Okay, I said substitution is equally as easy. Now, if I had eliminated x first, I would have found the complex numbers sooner. So I'll show you that using substitution method. Okay, if I want to find the imaginary solutions first, I would really want to get rid of the x's. So I'd like to solve. I'm going to take this bottom equation and I'm going to solve for x squared. X squared is equal to negative y squared plus 9. And we're going to plug it into the other equation. 9x squared plus 4y squared is equal to 144. Instead of x squared, I'm going to write negative y squared plus 9. Is everyone okay with this? This is why substitution confuses some people. You don't have to solve for y, right? Or for x. You can solve for x squared and substitute. So I solve for x squared and plug this in for x squared. And we get negative 9 y squared plus 81 plus 4y squared is equal to 144. If we add these together, we would have negative 5y squared, subtract 81 from both sides. That's 63. And divide by negative 5, y squared equals negative 63 over 5. Y equals plus or minus I root 63 over 5. And we can say no real solutions. I suppose not always, right? It could, if I had different y values that didn't have i's in it, I could have some real solutions. So when I substituted, I've used both equations, and these were the only possible y's. And since both of them had i's, I'd say no real solutions. Yeah. If I had these two y values and also y is equal to 2, then I might have a solution. I need to plug 2 in. Example 3 is about as bad as it gets. So let's go ahead and complete this one. One thing I'd like to point out is we can't use elimination yet in this form because the base of these are different with the -2 and the -3. We can't actually combine these yet. So what we're first going to do is expand. So what's x minus 2 squared? Can you FOIL that in your head? Plus 4. Very good. And this one squared. Very good. And you definitely want to get to the point where you can do that. Equation 2, using the same thing, we would have x squared minus 6x plus 9. And y squared plus 4y plus 4. Okay, and what I'm going to do is subtract R2 and add them together. So if I subtract R2, I'm going to make the signs opposite on all of these. Negative plus negative. And we're going to add these equations together because it's going to get rid of the x squared terms and the y squared terms. That will give me 2x minus 5 plus 2y plus 5 is equal to 30. Oh yes, it should apply to 10. Thank you. Equals 10. Any other questions? Okay, so I eliminated the squared terms, but I still have an x and y. -5 plus 5 is 0. I'm going to subtract 2y from both sides. So 2x is equal to -2y plus 10 and divide both sides by 2. X is equal to -y plus 5. So I used elimination, but I didn't actually eliminate a variable. So I can plug this in or substitute into either equation because I've already used both. Let's go ahead and substitute into either equation. I'm going to substitute into equation 1. So that would be x squared minus 4x plus 4 plus y squared plus 6y plus 9 is equal to 20. And we'll plug in, oh yes, plus 5, thank you. So -y plus 5, we're plugging in. All right, so if we FOIL this, -y plus 5, -y plus 5, we get y squared minus 5y plus 25. Then we have a -4 times a -y to make a positive 4y. -4 times a positive 5 to make a -20. Plus y squared plus 6y. And I'll go ahead and combine the 4 and the 9 to make 13. Y squared plus y squared is 2y squared. -5y minus 5y. So -10y plus 4y plus 6y They all cancel, right? Okay, so that's 0y. 25 minus 20 is 5, plus 13 is 18. Okay, so let's subtract 18 from both sides. 2y squared is equal to, or y squared is equal to 1. So y is equal to, let me square root both sides, plus or minus 1. Y is equal to 1, or y is equal to -1. Are there any questions about this? We used elimination to get rid of the squared terms, but we still had x and y. So we solved for x, substituted into either equation, and we finally found y. There's two y values, so we need to plug them in to either equation. And any form of either equation. So I'm going to call this right here, equation 3 or row 3. You can always plug into any form of either equation to find the x value. Is that true? These are two. What do these graphs look like when they're graphed? What does that look like? This would be a good final exam question. What does this graph look like? The circle centered where? At 2, -3? With what radius? Square root of 20. Very good. So this looks like what? A circle centered at 3, -2, radius square root 10. So this could have 1, 2, 3, or 4 solutions, or 0. Okay, I should probably plug these into either of those first equations. So I'm going to plug into the first equation again. So the expanded form of the first equation, the reason why I'm plugging into the first equation is because this plugged into an x squared equation will likely have 2 other solutions. If I plug into R3, this line, it will only give me 1 solution. This form is x squared minus 4x plus 4 plus y squared plus 6y plus 9 is equal to 20. I'm going to plug 1 in here, and I'll plug this one in the same equation. So I'm plugging in -1 this time for x. Okay, so I'll solve the purple one first. When y is 1, x squared minus 4x, and then I get, what is this? 1 plus 6 plus 9. 16 plus 4 is 20. Is that right? So x squared minus 4x is equal to 0. X times x minus 4 is equal to 0. So x is equal to 0 or x is equal to 4. Am I making errors here? Okay, so when y is equal to 1, I have 2 corresponding x values. I have x is 0 or x is 4. Any questions about that? Okay, so x squared minus 4x plus 4. If we plug in -1, I get plus 1 minus 6 plus 9 is equal to 20. So this corresponds to, is that 8? Okay, so subtract 20. X squared minus 4x minus 12 is equal to 0. Okay, so factors of -12 that add to make -4. X minus 6, x plus 2. X equals 6. X equals -2. So what we're saying here is when y is -1, we have 2 different x values. -2 and 6. So we have 4 solutions where these 2 circles intersect. Wait a second. Hold on a second. We can't actually have 4 solutions where 2 circles intersect, can we? With 2 ellipses, we could, but with 2 circles, we can't. Are these both circles? They are both circles. Does that make sense? 2 ellipses can intersect 4 times, but 2 circles, they would be the exact same circle and we have infinite solutions. So we can't have 4 solutions. We're going to have to check and plug these in. Okay, so when we plug 0, 1 in, so if x is 0, we would get -2 squared is 4. And y is 1, we get 4 squared is 16. So that checks out for 0, 0, 1. If we plug in 0, 1 on the bottom one, we would get -3 squared is 9. And 3 squared is 9. 9 plus 9 is not equal to 10. So this is an extraneous solution. We're going to cross it out. Okay, so let's try to plug in 4, 1. So if I plug in 4, 1, I would get 2 squared is 4 plus 4 squared is 16. So 4, 1 works on the top. On the bottom, 4 minus 3, 1 squared is 1. And then 1 plus 2 is 3 squared is 9. Okay, so it checks out for both. So this is in fact a solution for 1. So 6, -1, 6 minus 2 is 4. No, yeah. And 4 squared is 16. Wait, I'm plugging in. Yeah, 6, -1. Okay, so -1 for y would give us 2. Okay, so 2 squared is 4. And this is equal to 20. That checks out. And then if we plug in 6 here, we would get 3 squared is 9. -1. So we get 1 squared equal to 10. So that checks out. This is in fact a solution. And -2, -1. Okay, so that would be -4 squared is 16. -1 in here would be 2 squared plus 4 is equal to 20. So that checks out. And -4 minus 3 is 7. -7 squared is 49. And already it's not going to work. And then plus 1 is equal to 10 is not true. So we're going to cross out the solution. 4, 1 and 6, -1. Okay, I'm going to do a more difficult word problem here. We're limited on time. A painter leans a ladder against a vertical wall. The top of the ladder is 7 meters above the ground. When the bottom of the ladder is moved 1 meter further away from the wall, top of the ladder is 5 meters above the ground. What is the length of the ladder? We have a wall, we have a ladder. In the first picture, this side length is 7. We'll assume that this is a right angle. And we have an unknown ladder length. So I'm going to call that x. And we don't know how far away the ladder is from the wall. We'll call that side y. In our second picture, how's it different? We slide the ladder 1 meter to the right. So this distance is y plus 1. And the ladder length is the same. So that is still x. And the height above the ground is 5 meters. Does that bother anyone that we just scooted the ladder 1 meter to the left and it dropped 2 meters? That bothers you? You can find the rate that they're moving using calculus. It's an interesting calculus problem, related rates, yeah. It's unintuitive, right? Okay, how do we set up a system of equations here? What equation relates side x and side y? A, B, C for right triangles? What is that theorem? The Pythagorean theorem. A squared plus B squared is equal to C squared. Does that sound familiar? Okay, so in this case, we would say, which is our C? That's important. Yes. And the other sides aren't so important. Y squared plus 7 squared. So on the other side, we would have C is x, so x squared is equal to y plus 1 squared plus 5 squared. You want to use substitution or elimination? These are both solved for x squared already. So they're the same. And we can set these equal to each other. We can say y squared plus 49 is equal to y plus 1 squared plus 25. And solve the equation for y. So I'm going to FOIL y squared plus 2y plus 1 plus 25 is equal to y squared plus 49. Let's subtract y squared from both sides. 49 is equal to 2y plus 26. We'll subtract 26 from both sides and get 2y is equal to 23. And divide by 2. Y is equal to 23 over 20, over 2. Okay, what's the question asking for? Which is which variable? Okay, so I want to solve for x. How do I solve for x? Plug it into either equation. Maybe this one looks easier. So y squared plus 49 is equal to x squared. But y is equal to 23 over 2. 23 squared is 529 over 2 squared is 4. And getting common denominator, 49 times 4 is 196. So we'll add 529 and 196 to get 725 over 4. Square root both sides. So isolate x. X is equal to plus or minus. A 25 goes into 725 29 times. So we can write 5 root 29 over. Okay, and we're talking about the length of the ladder, so we just want the positive answer, 5 root 29 over 2 meters.